Sasol is a leading supplier of surfactants for hard surface cleaning applications. Sasol Chemical develops and markets a broad portfolio of organic and inorganic commodity and specialty chemicals. Our products are used in countless applications in our daily lives to add values, security and comfort. Examples include detergents, cleaning agents and ingredients for personal care products. Surface cleaners are used in a variety of household and industrial institutional applications. Formulated hard surface cleaners contain a variety of different raw materials depending on the application. One of the main frame surfactants for hard surface cleaners is alcohol ethoxylates, which are based on detergent range alcohols. Sasol Chemical produces a number of detergent range alcohols for a variety of different applications. Sasol Chemicals produces alcohol ethoxylates using either KOH, which we call alphonic, or our proprietary narrow-range catalyst, which we call novel. Sasol produces a number of surfactants which are ideal for hard surface cleaning applications. Alphonic is the trade name that we use for KOH-based ethoxylates, and novel is the trade name for our narrow-range alcohol ethoxylates. We have a variety of different Ziegler-based alcohol ethoxylates that are ideal for hard surface cleaning. We also make a number of branched ethoxylates, and our TDA-based ethoxylates are ideal for hard surface cleaning applications. Other benefits of our novel 810 4.5 include their low viscosity, light-colored liquid products with low odor. They're excellent hard surface cleaners. They are extremely efficient at solubilizing fragrances. One of the tests we do in the laboratory is solubilization efficiency. Here we take a mixture of oil and water and we basically titrate it with surfactant until it becomes clear. We have two beakers. The beaker on the right contains our novel 810 4.5. The beaker on the left shows a leading competitive product for HSC, hard surface cleaning. As we add more and more surfactant, you can see that we're starting to solubilize the fragrance. We've looked at a variety of our products. In fact, we see that this enhanced solubilization efficiency is an attribute of our novel narrow-range technology. In almost every case, the novel narrow-range alcohol ethoxylate is more efficient at solubilizing the fragrance versus the conventional KOH-based ethoxylates. We add 20 drops of the cleaning solution to a black ceramic tile. And see here that in fact for our novel 610 ethoxylates we see very good gloss retention for the low mole of ETO. It's almost as good as water. We do see that N610-4 shows better gloss retention than competition. For hard surface cleaning, we use an inline abrasion tester. We've got an A6 soil that we use from ASTM. We apply that to a formica tile and cure that at 60 degrees in the forced air oven. We then add 10 ml of the cleaning solution directly to the soil. We clean the tile using a cellulose acetate sponge. The weight of the holder is about 450 grams, so we have about 1 pound of weight on the substrate. And then what we do is we measure the reflectance of the tile as a function of the number of abrasion cycles. An example of some of the data that we generate. Here we show that water takes very little of the soil off. At 0.5% surfactant, we don't see much soil removal till we get to very high abrasion cycles. As we go to 1% surfactant, we see that we start to see soil removed after about 10 abrasion cycles. Increasing the surfactant concentration to 2%, we see that the soil starts to come off after 5 abrasion cycles, and that as we increase the surfactant concentration to 5%, we see almost immediate soil removal. If we take the plateau for the reflectance value, we can calculate the soil removal. We have the soil removal as a function of surfactant concentration. Between 1% and 2%, we see a large increase in the overall soil removal. Above 2%, it more or less remains constant. We have done quite a bit of testing at 1% surfactant. Here are a variety of novel 610 ethoxylates. And as we go to higher degrees of ethoxylation, the overall soil removal actually decreases. Novel 6104 shows the optimum cleaning. Interestingly enough, if you measure the interfacial tension between the surfactant solution and soybean oil, you can see that the maximum cleaning occurs near the minimum interfacial tension. This is a trend we see in hard surface cleaning studies. We've done the same kind of study now we're using our novel 810 ethoxylates. As we increase the degree of ethoxylation, cleaning goes up to about 4.5 moles of EO, and then at higher degrees of ethoxylation, the overall soil removal decreases. A similar study done on novel 1012 ethoxylates, as we increase the degree of ethoxylation, cleaning efficiency goes up. We see our maximum cleaning at 6 moles of EO. Optimum cleaning occurs near the minimum in the interfacial tension. Our entire product line sort of ranks how the different product families perform. The thing to notice is as the alkyl change of the hydrophobe increases, the degree of ethoxylation required to get the optimum cleaning also goes up. We've got pretty good data for a variety of different products. Novel 6104 is a very good hard surface cleaning. Novel 810 4.5 is also a very good product choice for hard surface cleaning applications. Our TDA ethoxylates also show ideal cleaning performance in a variety of different types of hard surface cleaners. Thank you for watching. Please call if you have questions.